Good day to you all. In today's session, I am going to discuss you about the topic manufacturing process. From manufacturing process, how it is going to related to production tooling, and from production tooling, how it is related to industrial engineering. When we are talking about the manufacturing process, it starts with the drawing, right? So from drawing to planning, how the process flow take in the shop floor. This is what we are going to see in this particular session. I introduce myself as Dr. C. Bhagyanathan, Associate Professor from the Department of Mechanical Engineering, Sri Ramakrishna Engineering College, Coimbatore, 22. So, I am going to start with a simple sketch. The simple sketch starts with a rectangle, right? What you see is a simple rectangle. In point of the layman or from the other departments allied or unallied with the mechanical engineering sciences, what they will say, or even you, when you see this picture, what you will say? It is a simple rectangle. But as a good engineer, you should not say it is a rectangle. What you should say? I need some features to define this sketch or drawing. So, when you ask me introduce feature, what I am going to introduce a feature is, I am going to introduce a center line, right? I am going to introduce a center line. Now is it okay? Again I will say it is not okay. See, I have center line, right? So let us take my dimension is 20. Okay. Now I put equal here and here. So what happens? Here I have 10 mm, here I have 10 mm. That's what. So again, the feature is not complete. What? What next? I have to give another view. Okay. So what is the next view I can do? I can just go for a next view. Okay. Next view. So what is this view? I made a simple. I have made a simple, right, circle, right. I have marked a center line. So this says that it is not a rectangle. Now, it is a cylindrical component. It is not a cuboid like component, right. So it defines the what? It is defining the. It is a cylindrical component. What is the next stage? The next stage is, again, it is not complete. So we have to give the next feature. The next feature is nothing but your dimensions. Okay. Say 100. Okay. Say this is 20. So dimensions is the next stage. Again it is complete? I say no. Why? This may be a simple, I can say the stem of a plant, right? I can say like that. I can say it is a stick, right? It is not an engineering component. Even though I have given the dimensions. See, if you are an engineer, I can say it may be 105 mm length because it is an open tolerance. You know about it. You may have already studied in your engineering graphics or machine drawing. So it is an open end. So it is 100, 3-digit number. So it will be plus or minus 3 mm, right? 103 or 97. Similarly, 20, it may be plus or minus 0.3 mm or 0.4 mm. So it can be a forged component, cast component, or a machine component, right? So now I have not got satisfied. So what I am going to do is I am going to assign a tolerance. I am going to assign plus or minus 0.02 here, right? H7 here. Why H7 capped a small letter? You know that for shaft it is denoted by the small letter, and for the holes it is denoted by the letter capital. Okay, so we have defined the tolerance. Sorry, I have to give a, for any circle I have to give like this. You have to make center line on both the axis, x and y axis, right? So I have center line here, I have done everything, fine. Okay, I have done everything, it is fine. Is it okay? Still I say no, because this H7, okay, this H7 can be performed by a conventional lathe or CNC lathe or a grinding machine, cylindrical grinding machine or centralized grinding machine. Am I right? So this should be have some tolerance or geometric tolerance. For this geometric tolerance, you have N8 finish. What is the N8 finish? N8 na we have 2 triangle. N6 na you have 3 triangle or RA of 1.2 or RA of 0.8. Okay, you might be heard about these terms, right? So this, since it is H7, I should give 3 triangle finish, right? In the, where I have given here, I have given it in the diameter. Now I have to give it in the length, right? Right. So all both these sides will have 3 triangle finish, nothing but grinding operation. Now tell me, is the drawing complete? Still I say no, because as I said earlier, we go with what? Understanding the sketch. Understand sketch. Okay. From the sketch, you go with manufacturing or machining process, right? Right. So if I want to do the machining process, how can I have introduced geometric tolerance and everything? So what should I do? I should give the between center, right? So the 6th term is between center. I have given the between center over here for machining process. What is the next stage I have to introduce? I have to make raw material selections. What is raw material selection? It may be a cast iron, right? It may be a steel, okay? It may be a aluminum or it may be copper. So what are my case may be, I have to give the raw material selection. This is the next case, okay? So now tell me, is it complete? Is all the drawings are complete? Is there any missing dimensions? I will say that it is not complete, because I have machined and done everything. Now I am going to drop this particular component in the floor. What happened? See, in this portion I am getting damaged. What happened? Here I am getting damaged. Okay, here I am getting damaged. What happens? I am going to insert this particular pin in a fixture plate or base plate or height plate, or it is going to be acting as a double pin, or it is going to be acting as a clamping pad. What happens? Will it slide inside the mating part in the hole? I will definitely say no. Okay, so it should not get damaged. When it should not get damaged, what should provision you have to make? Yes, that is nothing but your chamfer. You have to give chamfer over here, right? You are giving chamfer over here. Okay. Now tell me, is all conditions satisfied? I will say most probably, right? So now we have understand how to do the sketching and what to take from the sketch, right? The second thing, you are going for a manufacturing process. Okay, for the manufacturing process, what I am going to do is, I am again draw this. I am going to again draw the sketch. Okay, I am again drawing the sketch. Okay, I am going to introduce some additional features, right? Additional features. What I am going to do is, okay, I am going to make an additional feature like this. So I am going to introduce additional operations. So that second topic I am going to touch is about the machining process, right? So I am going to touch about the topic machining process. So this is dia 20 H7. Let us say dia 25 H7, right? Here it is 100 plus or minus 0.02. It is 20 plus or minus 0.02, right? Again, I just want to say one more thing in the sketching itself. What you should take care of, since you are going to be an engineer, you should not do this dimensioning like this. You have standard. Here is a line. I am going to make this thing, right? So it should be 3 times, right? Okay, 3 times of this dimension. Say if it is a 1 mm, the height should be a 3 mm. That is a standard. You should remember, right? Now I redefine the sketch like this. Okay. So I have a center line here. I have center line here, right? Center line here. So I have added one more feature. So now the shaft became what? The shaft or pin became stepped shaft. Okay. I am going to add one more feature. Okay, one more feature. So I am going to have a slot here. Okay. Why this slot is looking like this? What is this arc? See, the cutter will be like this. Am I right? So the cutter, this arc will be this thing. So that is why I mentioned arc like this. So let us say this dimension is dia 8 plus 0 plus 0.02, right? And where I have to, this is a cutter end point. So this dimension is 35 mm. Okay, 35 plus or minus 0.1. Okay, this may require. So this will be a keyway slot, or it should be a locking pin, or it is a cartridge pin, or so and so, right? Similarly, I have a across flat over here. What is across flat? What is across flat? To make a tightening or loosening the bolt. So we have a across flat over here. Let us say the across flat have a dimension of, say it is a 25 mm. Say it is have a dimensions of 15 mm over here, and here I have 5 mm. Okay. So what is the requirement for across flat? To use your spanners or to use our clamping device for tightening or loosening, right? So now I am going to add one more feature. If you remember, I had made a chamfer over here, right? Right? I am having a thread cutting over here. Okay, I am having a thread cutting. Okay, it is a 20 mm, no? So I am just having a thread cutting for 10 mm. Okay, I am going to tight. So since I am having a bolt here, I am going to have a thread cutting here. 10 plus 0.1 mm, right? So it is a M20 bolt, M20 into 1.8. Right? Now we have completed the sketch. Okay, we have added few features to complicate the sketch. So we had a simple sketch over here. Am I right? We had complicated the sketch by adding the additional features and adding additional dimensions and additional features. Right? Features in the sense, here slot is a feature. You have what are called a stepped bolt like thing, and you have thread as a feature. Okay, so we have different features, and we have added one more stepped shaft, etc. Right? So we have added lots of features into this particular drawing. Now we are going for a machining process. Okay, before going for the machining process, what I am going to do is I am going to select the raw material. What is the maximum dimension? 25. When you have the maximum dimension of 25, okay, when you have the maximum dimension of 25, okay, if you see the, okay, I have given the material. Okay, for raw material I will just make this component is made up of EN8. Okay, and I have not mentioned about the heat treatment. I am going to mention heat treatment of 25 HRC. Okay, what is the normal EN8 hardness value? It will be around 15 HRC, right? So from 15 HRC I am going to make it as a 25 HRC. So this is my requirement. So I will just take the raw material 25. If you take the standard bar, round bar size, after 25 you get a round bar of dia 32. Okay, all dimensions are in mm. You need not get confused at any stage. Okay, all dimensions are in mm. Okay, so I have selected the maximum raw materials. You know that round bar will comes in the range of 2 meter rod or 3 meter rod or 5 meter rod, etc. Right? So whatever the length you require, you have to cut it. What is the length I need? And I have mentioned the quantity. Quantity is 3000 numbers. Okay, quantity is 3000 numbers. Now, what I have to do? I have to take the length is shaft and I have to cut the component for how much? Length, calculate the length. I have 100 plus 20. Okay, this is a required dimension. Required dimension, am I right? So you have facing elements of, cutting elements of 2 plus 2. Cutting. Actually it is not required. 1 plus 1 is for fine. Let us assume the taper and everything. So it is for since it is for a preliminary study, we are going to make a higher value. Okay, 2 mm is sufficient, but anyway we are going to take additional of 2 mm. Okay, then facing allowance of rough facing of 1 plus 1. Okay, so how much? It should be 120 plus 4 plus 2, 126 mm. Okay, so raw material size is dia 32 by 126 mm. We have selected the raw material. Now we select the machines. Okay, we select the machines. So what are the machines you need? So we need to know what are the operations. So what are the operations we have? What are the operations we have? We have, what are the operations we have? We have cutting. Am I right? 1. We have to make a by, you know about process road. We say operation sequence number is 10, 20, 30, 40, 50, like that. So operation 10 is cutting. What is operation 0? Selection of raw material, right? 10 is cutting. What is 20? Your turning. 1. 30 turning. 2. Okay. Next is you have slotting, right? Slotting. Across flat, right? Right, across flat. Across flat, right? For these two things you need a vertical machining center. Okay, as I said earlier, harness, no, harness is 25 HRC, right? HRC. So you need a heat treatment shop. Operation number 70 is grinding. Operation number 8 is rust prevention. Right? So I have given you the operations in sequence order, like cutting, turning to slotting, across flat, so and so. So now we will just, based on this operation, we will just classify the machines. What are the machines we require? We need a cutting machine, cutting or bandsaw or hacksaw. Okay. 2 is CNC turning center. Third is vertical machining center. We can outsource heat treatment facility. We can have a grinding. What is grinding? It is cylindrical or centerless or surface grinding. It should be a cylindrical or centerless grinding. Okay, so these are the machineries you require. So for which you have assigned a sequence number 10, 20, 30, 40 and 50. Okay, so I will just go with machining processes. Now I just have an introduction about the a simple tooling, and I will end today's session. We will have a detailed discussion in upcoming sessions. So I will just go with a simple single work holding device. So this is a shaft. Okay, so the raw material will be looking like. This is the raw material, right? It is dia 32. What is this dimension? What is the dimension? 126 mm. Okay, 126 mm, right? So anyway, for roughing, what we will do? Rough facing. Here I am going to do the facing operation. Here facing operation. Okay, and I am going to do rough turning operation. Maybe for 0.5 or 0.4. For roughing, how will you hold? You hold by a 3-jaw chuck. Okay, so this 3-jaw chuck is a work holding device here. Okay, after doing the roughing, what I will do? You just go for the CNC turning center. In the CNC turning center, what you have? You will have the soft jaws. Okay, so I have introduced today. I have introduced about what? I have introduced about the sketching. Okay, sketching. Okay, from sketching, we went for selection of machine tools. Okay, third, we have introduction on soft jaws. Okay, so what we will do is, in the upcoming sessions, with the introduction, we will go ahead with the selection of cutting tools. Right, you have to select proper cutting tools. You have to do the proper work holding, selection of proper work holding device. You have to select the proper inserts, cutting tool inserts. You have to do the proper selection of process route. Okay, so all these things we will just see in the upcoming sessions. If you have any queries, you can just mail me. My mail ID is given below. Okay, thank you.